Hi, I am Tanya Janca, and today I would like to talk to you about 30 tips for secure JavaScript. Um, yeah, you might be thinking, where are we going to talk about today? So we are going to talk about writing better JavaScript because if an app is wildly insecure, it can't be the best. It can't be extremely high quality, right? And so if we are writing secure JavaScript, it'll be better than insecure JavaScript. We're going to talk about what to do and what not to do. And as a bonus, we're going to cover a bunch of free tools. We don't have much time, so let's go. Okay, so first of all, the job description, but then what we actually do. Yeah, I'm a little silly at times. So who am I? I'm Tanya Janca, and this is the mandatory about me slide. I seem to have my quotations on the wrong part, but every every presenter, every person at a conference that does a talk, we do this about me slide, not because we want to talk about ourselves, but because we're trying to convince you that we are competent and that you should listen to our talk. And so allow me to attempt to impress you. So I give secure coding training at my own little company called SheX Purple Consulting. I am the author of Alice and Bob Learn Secure Coding and Alice and Bob Learn Application Security, and me and my mom both agree they're pretty good. I have worked in tech since 1997. I started the moment I was legal. I founded some things. So I started a company called We Hack Purple, which got acquired in 2023, an OWASP project, an OWASP chapter. I love those guys. I'm a big part of that community. I am a lifetime distinguished member, so I'm obsessed with the security of software, just like the rest of my community members. Um, I I run this thing every Monday since 2018 on social media called Cyber Mentoring Monday, where I help people find mentors. I started an international nonprofit for women in cybersecurity called WOSEC, Women of Security. Um, I was a software developer for around 17 years before I switched into the cybers. Um, I'm an advisor at two startups, Smithy and Catalyst. I am a contributor to the OWASP Top 10, if you've heard of it. So we're just writing a new one. It comes out, well, by the time, yeah. So yeah, it's out. I write blogs for Stack Overflow, and like lots of other places. I am a board member for a nonprofit for another one for women in cyber. Yeah, so I do a lot of things, and hopefully you're like, she seems pretty tolerable. So now let's talk about JavaScript instead. So JavaScript is the front end of the entire internet. It's what makes it beautiful and responsive and changed the internet from pretty boring to pretty amazing. Um, but because JavaScript's so wildly popular and because it is the front end of all the web, it is riddled with cross-site scripting and other types of vulnerabilities and attacks. And it's a giant target as a result. And so I want to help all of you write more secure JavaScript. That's why I wrote this talk, why I wrote my book, why I give training all the time, why I do what I do. I want to meaningfully change our industry for the better. And I want you to help. So you might be thinking, why does secure code matter? I live under a rock. I didn't know that security was a problem. Um, so let's say you missed the memo. Secure coding matters now. Customers care. Customers ask about security. My parents bought a TV, a smart TV, and I was like, what? Are you going to connect that insecure piece of crap to your network? And they're like, guess what, Tanya? We read the fine print and it's had a pen test and it passed. So yeah, we bought a smart TV, and I was so impressed with my parents. So customers care about security. You can literally go out of business if you have a bad enough cyber attack. In Canada, because I'm Canadian, so that's the accent that you're probably hearing, um, 50% of small businesses just go out of business if they have a major cybersecurity incident. That's terrifying. Half of Canada works at a small business. So it's a really big deal. If there's like plausible deniability basically is not an acceptable excuse anymore. Customers expect better. We need to build and maintain user trust. We need to meet compliance standards. We need to protect our users' data, avoid business disruption. We do all of these things and become a brand that people can trust by building tough, rugged applications. And some of those applications are built with JavaScript. And so let's talk about how we can do better. I just have cute pictures of nature for the whole presentation because I like nature. Okay, so first, we need to do output encoding. If we're going to use JavaScript, we're going to display stuff in a beautiful web browser. We want to use a JavaScript framework that automatically outputs and code everything for us so we don't have to do that manually because it is easy to get wrong. So we could use things like Vue, React, Angular, all of those are so good. However, you should be careful because there are dangerous functions within these frameworks that I'd like you to avoid or use with extreme caution, such as React's dangerously set inner HTML, Angular's bypass security trust as functions. I'm going to have cheat sheets for 2 of the 3. I haven't got around to making the 3rd one yet. And a JavaScript security cheat sheet at the end of this presentation. So stick around, don't go anywhere. So number 2, follow a secure system development lifecycle. And yes, this applies to every single programming language, but you might be thinking, what is a secure SDLC, Tanya? So the system development lifecycle is the steps that you follow every single time when you build software. And a secure system development lifecycle means you've added one or more security activities to each phase. DevOps, Agile, Waterfall, whatever you're doing, it's fine. But you want to add an activity that basically ensures that part is safe. So for instance, when you're doing designing, you might do a threat modeling activity. When you're gathering requirements, there should be some security requirements or security user stories. Running scanning tools like stack analysis, software composition analysis, secret scanning, dynamic scanning. There's so many different types of security testing you could do. Following known secure design concepts and patterns and architectures, doing a secure design review, doing secure code. There's so many things you could do, but the key is doing it every single time. Yeah. Okay, so the next one, take cross-site scripting seriously, or XSS as some of us call it. So JavaScript is the only language that cross-site scripting was invented for. And it is a form of injection vulnerability. But unlike all the other injections, like LDAP injection, XML injection, command injection, SQL injection, all those types of injections attack us, the IT people, attacks us. Cross-site scripting attacks your user directly. That sucks. So we need to take it seriously. And we can do this by following this little recipe. We perform input validation and then either sanitization or escaping if we need special characters. Then we perform output encoding. Then we use the content security policy header. And on top of that, to be extra awesome, we add the HTTP only flag on our cookies to protect our cookies and our session ID and that sensitive data that's inside our very nice secure cookie from JavaScript attacks, i.e. cross-site scripting. JavaScript or cross-site scripting is an attack designed only for JavaScript. And a lot of this presentation is just going to be over and over again, different ways to avoid cross-site scripting. It has gone down in previous years. Like it's gotten better and better, but it's still in a lot of places, companies still get owned. And quite often it's cross-site scripting plus some other problem leads to sensitive data exposure, data breach, etc. Bad stuff. Okay, so a bit more. Cross-site scripting, let me explain it to you, is when your app confuses user input, so something that should be treated as data, for instructions. It's like, oh, is this code? I should execute this code. Okay. No. It interprets the malicious actor's JavaScript as if it was part of your app. And it executes with all the same power and all the same access that your JavaScript has. So, and if you don't have something like content security policy header to block it, it can do a lot of stuff. Yeah, cross-site scripting sucks. So again, the recipe: input validation, sanitization or escaping, output encoding, content security policy header, and then HTTP only flag on your cookies as well to also protect your cookies. Yeah. Okay. So another thing we want to do is we want to avoid inline scripting. So mashing together our HTML and our JavaScript. As tempting as it might be to like just put scripts right inside our HTML, it makes it so much easier for cross-site scripting to happen by accident. It's best to power JavaScript in a separate file to help us maintain separation. And it sounds weird, but it helps us just do security a lot better. Then you define all your scripts in the content security policy header, CSP. This is similar to doing inline SQL, inline JavaScript, where we combine user input and then feed it directly to the database to execute. It's really easy to like therefore mix up in like data from the user accidentally as JavaScript we should execute, which results in cross-site scripting. So instead, if we could do things like so if we must, which we shouldn't, if we could use quoted data variables instead. So think like source equals, and then you quote it to make it clear. This is text. This is not code. But it's even better if you just don't do it. Okay, next, 5. Treat user input as something to display or save rather than making decisions in your app. This is how injection happens. So if we always treat it as something that we display as opposed to something that we will use for logic and decision making, so many, like just most of the instances of cross-site scripting would disappear. If we apply this rule or guidance as much as possible whenever we can, we will do better. If you're not going to do that and you are going to take user input and make a decision with it, we want to validate it very, very carefully and then sanitize out or escape out any special characters and proceed with caution. Perhaps you would document this as well. So anything, and just as a reminder, input is anything the user gave you or could have changed, right? Like it's not just information from a text box. So like, let's say you have a hidden field. Yeah, a user totally could have changed that. Use text content or create element rather than inner HTML or outer HTML. Because inner HTML and outer HTML are dynamic, and the others are like, yo, this is text, treat it as text, never execute this. We should use encode URI component and decode URI component rather than just escape or unescape or just encode URI or decode URI. Again, these are more opportunities for cross-site scripting. Because of the component part, what this does is it breaks down every single piece better and more safely. With it's just more intentional way that we would take this. The parsing is better, it's more advanced, it's more modern. And so there are many types of attacks that focus on URLs, and some of them can bypass escape. And so we need to be careful. Ideally, we would use create element or append child rather than document.write. Again, this helps prevent cross-site scripting, but specifically DOM-based cross-site scripting, which is the crappiest, hardest to deal with one. These functions avoid inner HTML types of injection, and they use element properties instead, and those are static instead of dynamic things like text content or set attribute. When we set text into something that's static, that means for sure it won't be executed. Haha, it won't be rendered. We don't want that. Ideally, we would not use unescape HTML. Instead, we would use something like he or Lodash, which are safer. Unescape HTML isn't standard JavaScript, and it's not best practice. It also doesn't really decode things quite right, meaning it could allow dangerous characters by accident. Not all of them, but just some of them. And some of them are enough. There's also many other better things that you could do instead. And so ideally, we would use he or Lodash. I think I said this already, but we want to use decode and encode URI component rather than just decode or encode URI. And the reason for this is, so we want to pair them together, the ones with component. And basically, the URI components are anything that lies between the separators. So basically everything from HTTP all the way till the very end. And all of it is encoded rather than just parts of it and treated as text instead of special characters. Each component is capable, like the component function is capable of decoding more characters, including special characters, ones we might want to use. Decode URI and encode URI aren't as advanced. If we might just be given a fragment of a URI, we might not be given the whole thing. Decode URI handles it better. Number 11, make sure to URL encode data before passing it to the CSS URL method. You might be surprised to learn this one doesn't do it for you. The rest do, and this one doesn't. When we're in the execution context, so we're working in the DOM, we need to double encode. We need to URL encode and then JavaScript encode. Yes, you have to do it twice, and yes, it totally sucks. You have to do it twice if you are going, especially if you're going to use anything from that is user supplied data that we are going to put into the URL attribute. Yeah, we need to be safe. And this is what happens when you nest things. You have to do nested encoding, which is a mess. We want to take away superpowers between the script tags. So if we're in the execution context, so this means we're doing inline SQL, or inline JavaScript, which we should not do. We want to basically use text content assignment property to set text or string content. So this takes away any superpowers and makes sure it won't be interpreted. So basically when we're like, whatever our element is, .text content equals blah, 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 we're saying this is text, only treat it as text. Do not render this. Again, safer. So speaking of which, we want to always make it clear what is text whenever possible. So if we're getting something from the user, if we could specify that text is text. So saying inner text or text content rather than inner HTML, which is rendered, right? So if we don't do that, we put it in inner HTML and we're like, oh, it's obvious it's just text. Then you're letting the DOM decide for you, and sometimes the DOM gets it wrong. 15, when setting element.setAttribute, we want to use safe, static attributes that will not be rendered. And the list is very long. Big check mark, right? We want to use stuff like that. We don't want to use things that are dynamic, like on click, on blur, on mouse. Anything that like happens with an action, we don't want to do that. That is where cross-site scripting likes to hang out. Okay, so I wanted to give you like a longer list of more unsafe dynamic attributes. So event handlers, form control, href, source action, Boolean flags, all of those are dynamic and potentially unsafe. So don't put user input in there, please. Okay, so when making bad choices, and by this I mean inline JavaScript, because we've washed our hands of this, we're not doing it anymore. We want to set content type header to application or JSON if that's what we're doing. So if you're doing inline JavaScript, which we should not do, and you're using JSON, using JSON's good, just to be clear, it's not bad. We want to verify that it's not set to text or HTML, because sometimes attackers, what they'll do is you're expecting JSON and they send something that's not, or vice versa. And so you want to be explicit about what you're using, because then it will interpret it as JSON and not as something else. A lot of attackers try to confuse types and confuse protocols to get around the defenses that are built into those protocols. So let's be explicit about what we're doing. So variables, and by that I mean usually user data, right? That's usually what we're putting in a variable, should only be placed inside CSS properties, not into a context. So for instance, see how we're setting the property to the value? So then again, it's being used as text, all the superpowers are being taken out of it, rather than if you set it into a context, then it might get interpreted. We should turn on strict mode in every single language. That's it. You should just turn it on. It's safer. We want to avoid yet another type of injection, which is called HTTP parameter pollution, or HPP. So basically, it's where an attacker sends multiple parameters, like extra parameters, with the same name for the rec.query or the rec.body, except for obviously their values are an attack, they're malicious. So we can use either the HPP module with Express or HPP middleware, or we can write code, custom code, to defend against it. I have had a bunch of clients have these types of attacks and that they suck. So if you're going to write it yourself, input validation on the server side, plus sanitization and or escaping, and then also configure your framework against it. I know, another vulnerability to defend against. Lame. And there's some libraries. So Express Validator, Joy, or Zod. DOM Purify is an open source project that is really good for like removing anything that is potentially dangerous if you're going to put it into the DOM. It is highly recommended by many, many security professionals. I suggest you check it out. Ideally, we would use sub-resource integrity. This feature verifies the integrity of any external scripts that you're using. So even if it's from a content delivery network, a CDN, you want to check that you are receiving what you think that you are receiving. It's a feature built into modern web browsers. It uses a cryptographic hash to verify the integrity of the internal script. Right now on the OWASP Top 10, like lack of integrity in software and data is one of the items, because it is a big problem. Whenever possible, we want to minify and bundle and then nonce. So this would be an additional layer of security. This isn't, if you have like really low threat model, like low risk for your app, maybe not. But you could use something like Webpack or something similar, and it just helps obfuscate your code, which means hide it and make it more difficult for an attacker to try to reverse engineer it and see how to attack you. We want to avoid cross-site request forgery, affectionately known as CSRF. If we're performing transactions in our app, basically you pass a secret token back and forth between the front and back end. And so if someone clicks on a malicious link and it tries to do a transaction, it won't have the secret token. And then you've just blocked that attack completely. A lot of the front end JavaScript frameworks will pass it for you, but you got to collect it and check it on the back end, or it doesn't do anything. We want to use both a static analysis tool and a linter. A static analysis tool will specifically look for security vulnerabilities, and a linter will help you with code quality, technical debt, and all sorts of other things. If we use both, I'm trying to show, I don't know what I'm trying to show you with it. If we use both, it's better. Oh, and then fix things that you find. Yeah. Okay, dangerous functions. Things I would like you to avoid, please. If I dragon, dragons are scary. We want to avoid the following functions. All of these are potentially dangerous. If you could just not use them at all, that would be the best. If you are going to use them with extreme caution. Get another developer to review your code. Ideally, get approval from the security team. All of these are highly dangerous. Avoid the with function. It breaks everything. It makes it so static analysis tools just don't work. It doesn't work with strict mode. There's like 400 reasons. It violates lexical scope. It just does like all these things that are not best practice. Please don't use it. 27, avoid functions of function constructors with a string argument. Do you want to know why? Because what's in that string is probably a variable and is probably something that you got from the user. And then here you are constructing something with user input. Please don't, we don't want to do that, right? We know what goes in variables, user input, that's what goes in there. 28, please be careful with set timeout and set interval. These are surprisingly, like, you'd be surprised how basically if we put user input in them, they can be attacked. There are other options you should use instead that are safer. We want to avoid JavaScript methods, which take code as string types. So those ones, right? So instead, what we would like to do is set the attribute inside the function directly. We don't want it to take the method as it's being created. Instead, we want to instantiate and then set the specific thing. It's just so much better. 30, do not put untrusted data into HTML rendering methods. So what renders stuff? Inner HTML, outer HTML, document.write line, etc. If it renders, we never ever want to put user input in there. Oh my gosh, another type of injection, right? We want to avoid prototype injection because JavaScript is a prototyping language. And so basically it's where this attack is where an attacker manipulates or overwrites properties on a global object's prototype. And then the JavaScript language uses prototypes for inheritance. And if an object doesn't have a property directly on it, JavaScript looks up the prototype up in the chain of inheritance and then is like, oh, I'll use that. If an attacker manages to change the prototype, every single object that inherits from it is potentially negatively affected. That's bad. So we want to freeze the default object that everything else inherits from using object.freeze. We want to explicitly create objects that do not use prototyping, so we set it to null. We could use map instead of object, or we could just avoid recursive functions altogether. So you have a lot of options here. Ideally, please use one of them. Number 32, I know it said 30 tips for secure JavaScript, but there's more than 30 things. Please don't mess with the same origin policy. So the same origin policy prevents one website from accessing data or resources from another unless they're shared internally. So don't set the same value for like document.domain in order to share information between two pages. This ruins all the protections that it creates from the same origin policy. Instead, we should do something like, also don't, so we can send window.post message, but don't set it to star because again, it's a limit. And then what we're doing is we're like breaking the origin, right? And then when we do window.post message, we want to check where it came from and that it came from the place that we think it did before we use it. And so basically, and then what we get, we want to validate it just in case, right? So if we're going to share things between two different domains, like two different pages, we want to do it intentionally. We want to do it safely. So please don't like undo all the protection of same origin. If we're going to do input validation, unless we're doing a SPA, single page web app, if we're going back and forth between the front and back end, true validation happens on the back end. For the front end, we could do it again to save time and have it go fast, but the final security decision needs to be on the server, which is a trusted system that we completely, fully control. Although this applies to every programming language that is on the web, the front end is usually written in JavaScript, and thus it's worth mentioning. Seriously, prefer private variables over global variables. They're less likely to be accessed by external scripts. This is true again for all programming languages, but I wanted to mention it because I see this problem with web apps sometimes. So now for some free tools. So these are free JavaScript specific tools. So there's DOM Purify, retire.js, npm audit, yarn audit, subgraph community edition, horosec, node.js scan, bearer, and DOM snitch. Some of these work with more than just JavaScript, but all of these can help you write better JavaScript. And so in conclusion, what did we learn? Hopefully we learned a bunch of insecure functions in JavaScript that we should avoid, better, safer alternatives that we should use instead, a lot of ways to avoid cross-site scripting, a bunch of free tools that maybe we should try out, and the secure coding totally matters. Okay, so I have some resources for you. So if you are a Canadian, I have a petition to try to get people, basically to get the government to adopt a secure coding policy that I wrote. So if you're a Canadian, consider signing my petition. I wrote books, and like I said earlier, me and my mom agree they're pretty good. So if you write code, you should get the yellow one. If you want to build a security program, an AppSec program, you should buy the purple one. I have a newsletter and it is free. It comes out every month. And basically I just give away a ton of free content and invite people to events like this. So check it out. If you liked this could be the beginning of a long-term relationship. I am SheHacksPurple on all of the different mediums that are out there. So if you see it, it's me. Also, I have some treats for you. So I have a JavaScript cheat sheet, a React cheat sheet, a Vue cheat sheet, and basically they're best practices. So all the things that were in this talk are summarized in the JavaScript cheat sheet. So check these out. And if you wanted to get a copy of my presentation slides, that link is that right there. You can follow me on LinkedIn for the left or learn from me on the right. And with that, I am Tanya Janca, also known as SheHacksPurple, and I hope that you are convinced that you should write secure JavaScript. Thank you.